2015 BC Calculus, question 6, part A. So we're given a Maclaurin series as the sum from n goes from 1 to infinity of -3 to the n minus 1 over n all times x to the n. And they also expand it out for us just in case you can't put in 1, 2, 3, etc. And they say that it converges to some function, which is the function this is a Maclaurin series for all x's whose magnitude are less than r. R is the radius of convergence. So we want to use the ratio test to find r. And the idea for the ratio test is we want to say that the limit as n approaches infinity of the n plus first term over the nth term has to be less than 1. And the absolute values can go in a few spots, but that's the idea there. So they give us the nth term right here, so let me write that to the side. We know that the nth term is going to be -3 to the n minus 1 all over n times x to the n. So this statement here says, okay, well then let's consider the limit as n approaches infinity of the absolute value of the n plus first term. So everywhere I saw an n, I'm going to put an n plus 1. That would give me, I guess more space, -3 to the n plus 1 minus 1. So it's going to be to the nth power all over n plus 1 times x to the n plus 1 all divided by, and then I just put in this, t sub n, -3 to the n minus 1 over n times x to the n. And that has to be less than 1. And now I'm going to sort of work things out, and this is the way I sort of like to look at it. So this all implies that the limit as n approaches infinity of this -3 to the n is in the numerator of the numerator. It stays in the numerator. This n plus 1 is in the denominator of the numerator. It's going to be down in the denominator. And if you're smarter about this, you can sort of line things up. I'm just going to put them first come, first serve type of thing. This is in the numerator, so that stays in the numerator. This -3 to the n minus 1 is in the numerator of the denominator, so it stays in the denominator. This n is in the denominator of the denominator, so it comes up to the numerator. And this x to the n is in the denominator, stays in the denominator. Alright, and so a few things to do. So we have -3 to the n and -3 to the n minus 1. That divided by that is going to be -3 in the numerator. We have x to the n plus 1 over x to the n. X to the n plus 1 divided by x to the n is x left over in the numerator. We have n over n plus 1. As n is approaching infinity, those approach 1. You know, it's going to be, if n is 1,000, it's going to be 1,000 divided by 1,001, which is close to 1. If n is 1,000,000, it's even closer to 1. So as n approaches infinity, n over n plus 1 approaches 1. And so I just basically have to say that the magnitude of -3x has to be less than 1. Now, in here, if I want to get this -3 out of the absolute values, I'll have 3 times that value of x is less than 1. Or the absolute value of x is less than 1/3. And so x is trapped between sort of negative 1/3 and positive 1/3 to make this converge. So r equals 1/3.